You may remember in our previous lessons that we were talking about the laws of exponents and the exponent rules and how to multiply. When you multiply, you add the exponents. When you divide, you subtract the exponents. Those notes are actually in 6-1, so you may want to pull those out because we're going to be using those rules again. But for today, the new part is that we're adding in fractional exponents. It shouldn't be new in adding or subtracting fractional exponents, but in talking about what they actually mean, that part we have not discussed. So we're gonna start by looking at this definition up here. It says that if we have a value that's raised to a fractional exponent power, that the number that's on the top of that exponent is going to actually be the exponential value. The number on the bottom goes inside your root. So if this was a 2, this would be a square root. If this was a 3, a cube root. A 4, a fourth root. And so we're going to practice just rewriting these problems and then see if we can simplify them after we've rewritten them. So this one, we're going to have 16, and it goes under a root. Inside the root is a 2, that bottom number, and then it's raised to the third power. And if you'll notice, they have that it could equal either of these things. But for most problems, this one is probably going to be more beneficial because it'll allow us to do some of these things without a calculator. So here's what I'm talking about. If I want to do this, which is this form, I would be taking the square root of 16, which is 4, then raising it to the third power, and 4 times 4 times 4 is 64. If I had written it the other way, so it was the square root of 16 cubed, I would have to raise 16 to the third power and then figure out the square root of that. Now, while that is the same value, 16 times 16 times 16 is a very large number, and I probably would not know the square root of it right off the top of my head. So that's why this one is probably not our preferred form. Okay, so let's take a look at this next one. We have a negative exponent. If you remember from your notes earlier, a negative exponent, to make it positive, we just move it down to the bottom. So this is going to actually be 1 over 27 to the 2/3 power. So now I'm using the rule that I have from today, and I know that I want a cube root, this number on the inside the root, of 27 squared. And the cube root of 27 is 3, so I have 3 squared, and 3 squared is 9. So 1 over 9. All right, also, we have previously talked about anything in parentheses raised to a power. This exponent goes with both of those, so this is 9 to the 1/2 power divided by 25 to the 1/2 power. And so each of those are going to be its own root. This one is the square root of 9 to the first power, and this one is the square root of 25 to the first power. And the square root of 9 is just 3, and the square root of 25 is 5. Okay, so we're going to be using this rational exponent rule or definition to simplify some problems. And it says that in this next section, we want to express these in the simplest form, and we want to always end using positive rational exponents. So we don't want to leave roots. We are going to leave positive rational exponents. That means fractional exponents. So to work some of these, I am going to need to take them into a fractional exponent form. So for this first problem, everything under this root is the 6th root, and everything inside these parentheses is raised to the 4th power. So every single bit of this, 27a to the -1, b to the 2nd, I can raise it all to the same exponential power, which in this case the 4 goes on the top and the 6 goes on the bottom. This number goes on the top, this number on the bottom. So for us, that's going to be 4 over 6. Well, we know that 4 over 6 reduces down to just 2/3. So all of this is to the 2/3 power. All right, so that goes with everything inside of here. So we have 27 to the 2/3 power, and then a to the -1 raised to the 2/3 power, power to a power. That's also in your 6-1 notes. You're supposed to multiply. So -1 times 2/3, -2/3. And then b to the 2nd raised to the 2/3. We multiply those. This is 2 over 1 times 2 over 3 would be 4 over 3 power. Okay, so for the 27 to the 2/3, that's what we were doing up there at the top. As a matter of fact, we have one almost exactly like it, except it was -2/3. So everything is going to be worked out the same as this, except it doesn't have to go in the bottom. So 27 to the 2/3 power, we're going to take that back into root form so we can simplify it. So we're going to have the cube root of 27 squared, and then the a to the -2/3 power. To make that positive, we move it to the denominator, and the b to the 4/3 power would stay in the top. So one last step, we're going to simplify this. The cube root of 27 was 3. We got that up here, right? And then 3 squared is 9. So this is just 9 b to the 4/3 over a to the 2/3. All right, fractional exponents, no negative exponents. All right, for number 5, again, we need to put this back into our rational exponent form, and then we can work with what we have, work with our fractions. And so this is understood whenever there's not a number in there. Just like an exponent is understood to be a 1, a root is understood to be a 2 or a square root. So this is actually x to the 1/2 power times, this is raised to the first, so x to the 1/3 power times, this one's to the first, so x to the 1/6 power. Now when we are multiplying, we learned that to multiply, we need to add the exponents. So I'm going to add all those exponents together, and I'm going to have x to the 1/2 plus 1/3 plus 1/6 power. But to add all those together, I actually need to get a common denominator. And the common denominator here is going to be 6. To change this to 6, I multiply by 3, so this is 3/6. So x to the 3/6 power. And then this one would be 2 multiplied by 2, so 2/6 plus 1/6. So 3/6 plus 2/6 plus 1/6. 5 plus 1 is 6/6, or just x to the first power, which is just x. All right, a couple more to go here. This one looks like distribution. We need to distribute or multiply this times each of the terms in the binomial. So when we multiply, we add exponents. So we're going to get 3x to the, and then -1/3 plus 1/3 would be 0 power, minus 3 times 4 would be 12x to the, and then -1/3 plus 4/3 would be 3/3 power. Anything to the 0 power is 1, so this is just 3 times 1 minus 12x to the first, or just 3 minus 12x. Okay, for our last example, we don't have any variables. So, since it's all numerical, I guess if you had a calculator handy, you could just type it in. But the point of this is to be able to do it without a calculator. And so we always work inside the parentheses first if we can. So inside the parentheses, these negative exponents just mean to move it to the bottom and make it positive. So we're going to have 1 over 2 plus 1 over 4. That gets rid of my negative exponents. These are just to the first power now. Raised to the negative 1 power. All right, so I just need to add 1/2 and 1/4. So I need a common denominator. I multiply this by 2 over 2, which gives me 2/4 plus 1/4. And 2/4 plus 1/4 is 3/4, and it's raised to the negative 1 power. But remember that negative 1 power goes with both of these. I have 3 to the negative 1 over 4 to the negative 1. And that, to make it each of them positive, I just switch where they are. So I just get 4 over 3. All right, so we are combining our fractional exponent rules using our definition along with our laws of exponents to simplify expressions.